Hello, and this is a video, of course, made by me. So you might be wondering, who is this incredibly stupid, dumb, and moronic idiot that's narrating the video? Well, you already know what the video's about. And second, hey, it's me. So, you might be wondering, why do you have to know this? Because I feel like it. Okay, time for the video part of the video, where I video the video because the video is a video. So, first things first. We know about matrix multiplication, definitely. So, you might have wondered, why is matrix multiplication the way it is? Well, I'll give you the answer. But first, something completely different. Imagine you have a vector. You want to rotate the vector by an amount. Now, there is an angle that's 90 degrees perpendicular, and if you make the vector face up, which you can do because of the symmetries of a circle, that means it's simply 90 degrees from it plus times the sine, let's call that A, and 90 and forwards from that point, which is the cosine, let's call that B. So we want to find the angle of A and B. So everyone knows how to make a 90-degree rotation, right? It's x equals negative y and y equals x. This simple fact lets us rotate. But let's say we're working with a vector. We can't do that because the vector's individual components are not separate. They're as a whole. So now you wonder, how can we make this? We could make something that just swaps. But now you think of the third dimension, the fourth dimension. You can't do that for those dimensions. So what instead you come up with is a square of numbers. The input vector is placed at the top of the square. The output vector is placed at the left side of the square. The input vector, each value of the input vector is multiplied by its corresponding columns numbers. Then the output vector, vector component is determined by the sum of all the values on its row after the multiplication. Now, obviously, you already knew that. So, where's the fun stuff? Well, matrix multiplication starts with going up a dimension into the third dimension. You can see that any three-dimensional rotation is two-dimensional rotations combined together. Now, you also might see those are two multiplications with two different vectors, and the first vector times the first matrix is the second vector. So if there was some way to multiply the two matrices, that would be pretty great. So how do we combine it? Well, the final vector's components have an index. The first vector's first component's effect on the last vector is its effect on the second vector's first component, second vector's second component, second vector's third component, each of those being multiplied by their effect on the first component of the third vector. So now we've seen that we can multiply the two matrices. And here's the thing, because the first matrix we were multiplying in columns, while the second we were multiplying in rows. That both explains why matrix multiplication sections or columns and rows, and why they do it in such a specific way. So, now that we know that, you can leave now. Fine. You can leave.